Hello everyone, welcome to engineering study and today I am going to cover index consistency of soil. This is my last lecture about index properties of soil and still some tests are remaining, that is oven drying method, sand bath method, sand replacement method, casagende method, and all of these methods first will be performed in the laboratory, then I will teach you how the theory part. Okay. So today we will cover consistency of soil. And what does that mean? If you take some amount of soil in your hand and then you mixed up some water with it and then you start remolding the soil, and the soil will deform continuously from its previous state to a new structure or to a new shape. Okay, and this deformation totally depend upon the water present in the soil. Okay, so percentage of deformation with respect to the water content is called consistency of soil. So now go to the definition part. Consistency of soil. Consistency refers to the degree of deformation. Consistency refers to the degree of deformation which may be recorded in soil due to change in water content. That means consistency directly related with the water content. The percentage of water present in the soil, okay, consistency is depends on it. So now the second point is it is used only for fine soil, silt and clay, not for coarse soil, gravel and sand. As consistency directly related with the water, that's why it used only for fine soil. Why? Because in coarse soil the void size are bigger and holding capacity of water in coarse soil is very less, but in fine soil voids are smaller, so they can hold the water in between them, and after that we can deform the soil into different shape. That is what consistency means. So that's why it is used only for fine soil. Okay, and next is consistency limit. Consistency limit generally means water content between any two stage is called consistency limit. And what are the stages? That is liquid limit, plastic limit, and shrinkage limit. I will come slowly about these limits one by one. Just know that there are three water content, that is liquid limit, plastic limit, and shrinkage limit. Now come to liquid limit. Liquid limit, by the name we can easily understand that when the soil will behave like a liquid at that water content is called liquid limit of soil. Okay, so it is a minimum water content at which soil is in liquid stage or soil have tendency to flow. Now guess, if you take some amount of soil in a beaker or in a pot and then you mixed up water in the soil, a certain stage will come when this soil have the tendency to flow like this liquid, and at that point the water content remaining in the soil is called liquid limit of the soil. Okay, as the soil will behave like a liquid, at that point soil have very negligible amount of strength, that is 2.7 kilonewton per meter square. And now determination of liquid limit. There are three tests are there: Casagende method, one point method, and static cone penetration method. This method will perform in the laboratory, and these two methods is obsolete in India. Okay, so first we will perform this method in laboratory, then I will give a presentation here, and then you will learn the details about this method, Casagende method. And now the second point is plastic limit. And what is that? What is plastic limit? And first learn what is plasticity. Plasticity means when we apply some load on a plastic material and that material will deform, and when we remove the load from it, the material will not go back to its previous position. There will be some amount of deformation that is unrecoverable. Okay, that is called plasticity of a material. Same for soil mechanics. Same for soil mechanics. When you deform the soil after mixing up with water, then the soil will get a new shape. You can't get the previous shape of that soil mass. Okay. So now plastic limit key. It is the minimum water content at which soil is in plastic stage of consistency. That means you can deform the soil at any shape and size, and that condition requires some amount of water, and that water content is called the plastic limit. At which water content the soil will behave like a plastic, that water content will known as plastic limit. And for determination, this test also will be performed in the laboratory. For determination of point of view, plastic limit is that minimum water content at which soil is rolled into threads of 3 mm, and then surface crack will just appear. You take a 3 mm dia soil ball and start mixing up water and start rolling it. Okay, and when you increase the water content and then you continue rolling, a moment will come when the surface crack will just appear on the ball, and that point, at that moment, the amount of water present at that soil is called plastic limit. Okay, and this test will elaborate in the laboratory. Okay, now properties plasticity index. Plasticity index is liquid limit minus plastic limit. Okay, this is plasticity index. Now write down a note here. Now write down a note here. The note is plasticity index or plastic range of soil, plastic range, RANGE, plastic range of soil depends on the types of clay mineral and magnitude of clay mineral present in on it. Okay, plasticity index depends upon the type of clay mineral or magnitude of clay mineral present in it. Why? Because consistency, as I defined that, it is only used for fine soil, seed and clay, and clay, the voids in the clay are more smaller in comparison with seed. So, and as the void will be more smaller, more amount of water will retained by the soil. So the plasticity, it depends on the amount of clay present in the soil. So now complete the note. Okay. Shrinkage limit. Okay, what we have learned: liquid limit, plastic limit, and now shrinkage limit. So what is this? First, what we have learned that WL liquid limit, then plastic limit WP, then we are going to learn shrinkage limit. Okay, and what we have learned here, that at liquid limit soil will behave like a liquid. Why? Because in a pot, in a soil, if you start adding some amount of water, a certain stage will come when, due to the excess amount of water, the soil will take the property of the liquid and it will behave like a liquid, or it will flow like a liquid. So that water content is called liquid limit. And now if we start removing some amount of water or decreasing some amount of water, then the soil will lose its liquid behavior and it will start gaining its strength. Okay, so first we learn that here we can easily understand that at this stage soil is 100% saturation due to excess amount of liquid. Okay, and when we start removing water, and the soil will start gaining its strength. Okay, and here after when a stage will come when the soil will behave like a plastic due to decreasing the amount of water. Okay, but here is also soil is 100% saturation. All voids will be filled by water. Okay, and now again we start decreasing the water. A stage will come that is called shrinkage limit. What is this? Okay, now look into this picture. This is a solid and water. This soil is 100% saturation. That means in plastic stage. Okay, and now if we start decreasing some amount of water, the volume will also decrease. Like here, the volume has decreased, and then again we start decreasing the water, the volume will also decrease. Okay, but again if we want to remove some amount of water, then a certain stage will come that the volume will be fixed and the vacuum space will be filled by air. That means here the soil is not 100% saturation. Here is also soil 100% saturation. Here is also soil is 100% saturation, and here also. But after this point, when we start removing some amount of water, the vacuum space will be covered by the some amount of air. That means this vacuum will be takes place by the air. And again, if we remove the water, the whole place will be filled by air. And so a certain stage will come when the we can decrease the volume of the soil, and that point is called shrinkage limit. Okay, look at here. From this point, when we start decreasing some amount of water, the air is taking place, the vacuum space. Okay, again if we decreasing some amount of water, the air will take the rest of the vacuum space. So from this point, we are getting a fixed volume of the soil. This point is called shrinkage limit. Okay, now read the definition. It is defined as the maximum water content after which, if water is reduced, volume of the soil will not decrease, or it is the water content at which soil is at 100% degree of saturation for the last time. Here the soil is 100% saturation, and if we start decreasing the water or remove the water, as the some air is taking place the vacuum space, here the soil will not be a 100% saturation. So at shrinkage limit, the soil is the 100% degree of saturation for the last time. This point is also important. Okay, and now below shrinkage limit, replacement of water by air takes place. Okay, below shrinkage limit, replacement of water by air. That means the air taking place the water space. Okay, takes place, and such that volume of the void is constant. From here, the volume of the void VV is constant. Okay, and volume of soil is also constant. Here is also V, and here is also V. Okay, it means when water decrease below shrinkage limit, degree of saturation will be less than 100%. That means if we decrease the amount of water from this point, the soil will have less than 100% degree of saturation. So this point is called shrinkage limit. Liquid limit, plastic limit, and then shrinkage limit. Okay. We are going to the determination of shrinkage limit. Okay. First we are going through the diagram again, that is solid and full amount of water, that means 100% saturation of water. Then we start decreasing some amount of water, and this point is called shrinkage limit. That means from here if we start decreasing the removing the water, the air will takes place. Okay, so this point is called shrinkage limit. And now the volume of the solid is Vs and weight of the solid is Ws. Total weight at the starting point is W1 and total volume at the starting point is V1. And here solid, and at the shrinkage point, okay, volume of solid is, as the volume of solid is constant, here Vs, here is also Vs, but the total volume of the solid is decreased, that is V2. And same for the all this part, total volume is constant, here is also V2 and here is also V2, but here we have removed the all amount of water, that's why it is dry stage, but the total volume is V2, but we can define at V2 as Vd, as there is no amount of water, we can call it as a dry stage of water, dry stage of soil. Okay, and now how we can determine the shrinkage limit? Okay, as now shrinkage limit, as the shrinkage limit, liquid limit, plastic limit is a one type of water content, so the definition is same, weight of the water by weight of the solid. Okay, now W1 weight, shrinkage limit is weight of the water by weight of solid. Okay, and now first how we can get the weight of the water? W1 minus Ws, we can getting the weight of the water first stage, but we require the weight of the water at this stage, shrinkage point. Okay, so we require to get this amount of the weight of this amount of water. Okay, so first stage, what is the weight of water? W1 minus Ws, then we removed this amount of water, and what is the weight of this? V1 minus V2, that means we get the volume of the water we remove, and if we multiply it with gamma W, V1 minus V2 into gamma W means kilonewton per meter cube, and the meter cube and meter cube will neglect each other, and then we'll get the amount of the water we have removed from here to here. Okay, then we are getting the weight of the water, and then weight of solid is a fixed term Ws, so we are getting the shrinkage limit here. And in method 2, if in any math this data is given, then we can get directly the value of shrinkage limit, that is V2 minus Vs, we are getting the volume of this amount of water, and we are multiplying with gamma W, then we will divide it by weight of the solid. Okay, now third stage and third technique, from here V2 minus Vs into gamma W by Ws, same value, and here V2 is defined as Vd, as no amount of water present here. Okay, and now we are multiplying it, Vd into gamma W by Ws minus Vs into gamma W by Ws. Now weight of solid by volume, that is dry unit weight. Okay, so gamma W by gamma D minus weight of solid by volume of solid, that is unit weight of solid. So gamma W by gamma S. Now gamma W by gamma D minus what is the definition of true specific gravity? Unit weight of solid by unit weight of water. Okay, so that is 1 by G. And now what is the value of gamma D? G gamma W by 1 plus E, and gamma W neglect each other, then 1 by E by G minus 1 by G. So value of shrinkage limit is E by G, that means void ratio by specific gravity. Okay, this is the interrelation between the three stages of soil, three consistency of soil, that is liquid limit, plastic limit and shrinkage limit. And this x-axis is, we are assuming that it is as water content, and y-axis it is a volume. And from here, liquid limit, plastic limit, shrinkage limit. The value of liquid limit is greater than plastic limit, the value of plastic limit is greater than shrinkage limit. So if we going to the origin, the water content value will decrease. Okay, and now here the amount of the water is very high, then we start removing the amount of water, and then we will start removing the amount of water, shrinkage point, and a point will come where we can't reduce the volume of the soil. That means if we start reducing the amount of the water, the volume of the soil is fixed in this stage, and this point is called shrinkage limit, what we have discussed earlier. Okay, so draw the graph, and this is very important for mathematical purpose. Okay, now tan theta equals to VL by minus VP, VL minus VP, VL minus VP on this value by WL minus WP on this value. Okay, and or VP means this value, and VS means this value by WP minus WS means this value. Okay, and same for VL minus VS by WL minus WS. Now all the values are same, that's why it is constant. Okay, so thank you for today, and next we will come for some tests. First we will perform that in the laboratory, and then I will discuss that test here. Okay, thank you.